Okay, the second half of the video, 4.8 absolute values. I just have two quick examples, but they were a little different than the other ones, so I wanted you to have an example of these. So if we look at this first problem, I already have the absolute values on a side by themselves, and they are equaling 0. So this is already in standard form. So I already have it in the correct form. Does this have a solution? Yes, it does, because it is not equaling a negative number. How many solutions? This is one that only has one solution because it equals 0. That was one of our scenarios up top. So what is my one equation? I drop the absolute values and have negative 8x plus 7 equals 0, and I want to solve this equation. So we subtract 7 from each side, which gives me negative 8x equals negative 7. Divide by negative 8. And I want to reduce the signs on this fraction. Two negatives make a positive. So my solution set, if they ask me to put it in the squigglies, I only have one answer, and that is 7/8. Okay, this bottom one looks kind of funny because it's kind of big, but it's the same as all the others. I need the absolute values by themselves, so I need to get rid of this plus 4. So I need to subtract 4 from each side, and then I have standard form. 6x plus 9 over 3 in the absolute value symbols. The 4's cancel, and 7 minus 4 is 3. So this is standard form. I would need to type that whole thing in if it asked me to. Absolute value symbols, fraction, and all. Does it have a solution? Yes, it does, because this is a positive 3. What are my two equations? Drop the absolute value symbols. So I have 6x plus 9 over 3 equals 3. That's one equation. And 6x plus 9 over 3 equals negative 3. That is my second equation. Then it may say solve. Okay, I see a fraction, so how are we going to solve that? We're going to use that common denominator. My common denominator is 3, so this big term gets a 3, and so does my other term. 3 goes into 3 one time. It cancels, so I'm left with 6x plus 9 equals 3 times 3 is 9. Solve this equation. We subtract 9 from each side. 9 minus 9 is 0. Divide both sides by 6. The 6's cancel, and I have x equals 0. Same process for the second equation. Multiply both sides by 3, so those cancel. And I'm left with 6x plus 9 equals negative 9. I subtract 9 in order to solve. The 9's cancel, and I have 6x equals, that's a 9, sorry for that little loop. Negative 9 minus 9 is negative 18. Divide both sides by 6, and I get x equals negative 3. So my two answers are 0 and negative 3. Remember, if the directions say solution set, you choose your squigglies from your keypad, you put in 0 and negative 3 separated by a comma. Now the very last example I have, it looks so simple, and it is. And it's so simple that a lot of students miss it. So I just wanted to make sure I went over an example of that one. It's not in standard form because absolutes are not alone. I got to get rid of this minus 4. So I need to add 4 to each side. So that leaves me the absolute value of x equals 0 plus 4 is 4. This entire thing with the absolute value symbols is standard form. Does it have a solution? Yes, it does, because 4 is positive. So yes, it has a solution. What are the two equations? Drop your absolute values. So one equation is x equals 4. The other equation is x equals -4. Solve those two equations. Well, they are already solved. X is on a side by itself. That's what makes this problem so easy, but students think they're missing it. This is already solved, so the two solutions are 4 and -4. And if it asked you to graph it, you would put a dot on 4 and -4. So again, just real quick to recap this section, remember to read your directions carefully. Sometimes they want you to go straight for the answer and just type in -4, 4 in the solution set. Sometimes it takes you through all 4 steps, making you break down the process as you go. So just pay attention to those directions, watch your signs, make sure you use the little keypad so that you can choose your absolute value symbols and your little squiggly symbols when needed.